So our goal for today is that we want to be able to balance chemical equations by applying the law of conservation of mass. And this is Unit 5, Lesson 2, Balancing Chemical Reactions. This is the basic anatomy of a chemical equation. You have your reactants over here on the left-hand side. That's what you're putting into the chemical equation. And you have your products over here on the right-hand side. Those are what you're getting out of your chemical reaction. So if you would think of like cooking, your reactants would be like your ingredients and your products would be like whatever you're cooking at the end. Maybe it's brownies, maybe it's chicken fajitas, whatever you're getting at the end, that's your products. If you can remember from the last class, the law of conservation of mass states that the mass of the reactants must equal the mass of the products in any chemical reaction. So how does that apply to you? Well, what we're going to do, we are going to use what are called coefficients to make sure that the number of chemicals or the number of elements that we have on the left side are the same as the number of elements that we have on the right side. So if we have 2 oxygens that we're putting into a chemical reaction, in our products we need to see 2 oxygens somewhere. So that's how we use those coefficients. They're going to be whole numbers. I have them represented as x right here. They won't all be the same. Don't get confused. It's not like if you have 1 in front of A, you need to have 1 in front of B, C, and D. Coefficients are just going to be whole numbers that describe how many of each molecule participate in a reaction. So when we apply the law of conservation of mass, we need to make sure that there are the same number of each atom on each side of the chemical equation. This equation, as written, violates the law of conservation of mass. So over here on the left-hand side, I have 1 aluminum atom. If you don't see anything with aluminum, you can assume there's 1 if there's nothing out front and nothing down here. Over here I have 2 aluminums because it says Al and then this little 2 means that I have 2 aluminums. That extra aluminum that you have in your product, it violates the law of conservation of mass. Same thing here, you have 2 oxygens, so this little 2 means you have 2 oxygens. And I have 3 over here in my products. So this chemical equation as written does not satisfy the law of conservation of mass. What we need to do is put coefficients out in front. Those coefficients will allow us to observe the law of conservation of mass. So here's the same reaction that we were just looking at on the previous slide. And this is the unbalanced one over here on the left-hand side. Over here on the right-hand side, this is the balanced form of the equation. And you can see those coefficients out front. So there's a 4 in front of aluminum, a 3 in front of the O2, and a 2 in front of the Al2O3. So we apply the law of conservation of mass by using these reaction coefficients so that we know that we have the same number of atoms on each side. Because if the number of atoms of reactants equals the number of atoms of products, then the mass of the reactants has to equal the mass of the products. Now I just want to go over how to read the coefficients and what they do to the numbers in your chemical equation. So if there's a 4 out front, it's going to apply to the aluminum. So that means we have 4 aluminums right here. It doesn't apply to this oxygen right here because there's a plus sign in between. So we have 4 aluminums on the left. We also have 4 aluminums on the right. So what you do here, you take this 2 and you multiply it by the subscript. So 2 times 2 gives you 4. There are 4 aluminums. We have 6 oxygens on each side as well. Like I said, this 3 right here, you multiply it by the subscript, which is 2. 3 times 2 gives you 6 oxygens. And then with this oxygen right here, you have to take this 2 that's out front. It applies to both aluminum and oxygen. So you take this big 2 out front, multiply it by the little 3, and you get 2 times 3 equals 6 oxygens. So there are 6 oxygens on each side. And that's how you know it's balanced, if you have the same number of each type of element on each side. It's kind of just like making a sandwich. Sorry to make you hungry again. If you have 2 pieces of bread and 1 piece of cheese, you can end up with 1 sandwich. That 1 sandwich will have 2 pieces of bread and 1 piece of cheese on it. Or if you take 2 pieces of bread, 2 pieces of ham, and 2 pieces of cheese, you'll end up with 1 sandwich. On that 1 sandwich, you'll have your 2 pieces of bread, your 2 pieces of ham, and your 2 pieces of cheese. So all of the coefficients don't have to be the same, and they're not. This is 2, 1, 1. This one's 2, 2, 2, 1. What has to be the same is the amount of each ingredient and then the amount that you end up with in your product. So if you have 2 pieces of ham over here, you better have 2 pieces of ham in your sandwich. Just like here, if you have 4 aluminum atoms as your reactants, you better have 4 aluminum reactants as your, 4 aluminum atoms as your products. If you have 6 oxygen atoms, your products need to have 6 oxygen atoms.